So now we're going to put everything that we've learned now together. So when we go to graph a rational function, these are the 6 things that you have to include on every rational function graph. So if I ask you to graph a rational function, you're going to give me the horizontal asymptote, the vertical asymptote, any holes that you have, the x-intercepts, the y-intercept, and then you need additional points to get an idea of the shape of the graph. Now, typically, you need about 3, but it really depends on the function. So sometimes you might not need any additional points. Sometimes you'll need 5, 6 points. Sometimes you'll need 1 or 2. So what you're going to do is once you get 1 through 5, you're going to graph all of that first, and then we'll decide what additional points we need. So let's jump into one. So what is the graph of the rational function y equals x plus 3 over x squared minus 6x plus 5? So I say to do the horizontal asymptote first because when it's in standard form, the way it's written right now, it's easy to see what the degree of the top and the degree of the bottom is before you factor it. If you factor everything first, it might be a little more difficult to see what the degrees are. So I'm going to jump right into this and put horizontal asymptote. Now if I look at the degree of the top is 1, the degree of the bottom is 2. So since the top is less than the bottom, my horizontal asymptote is y equals 0. So next thing I'm going to do is I'm going to factor. So I'm going to factor this function. So I'm going to keep the x plus 3, and I'm going to factor the denominator. So it multiplies to 5 and adds to negative 6. So I'm going to use negative 5 and negative 1. Okay, I want to see if I can cancel anything out, which I can't, so I'm going to leave that the way that it is. So the next thing I'm going to do is my vertical asymptotes. So since nothing was canceled out, I have 2 vertical asymptotes. So vertical asymptotes, I have x equals 5, and I have x equals 1. Next thing we have is our holes. Okay, because nothing was canceled out, there are no holes. So holes would be none. The x-intercepts, I'm going to take the numerator, so x plus 3, and I'm going to set it equal to 0. So x equals negative 3. So my x-intercept is going to be negative 3, 0. And then for my y-intercept, you can plug in 0 for x, or you can look at the constant terms. So if we look at the original problem, the constant terms are 3 and 5. So it's 3 over 5. Okay, and then I'm just going to write additional points, but I'm not actually going to pick any yet. Okay, so our last step is to find our additional points. But before we do that, we have to graph what we have so far. So we want to graph y equals 0 as our horizontal asymptote. So I'm going to make all of the asymptotes, horizontal and vertical, are going to be dotted lines. So we've seen that in the iPad activity. So all the asymptotes are dotted lines. So now I have a vertical asymptote at 5 and at 1. So I'm going to go to 5. And I have an asymptote this way. And at 1 I also have an asymptote. Okay, so if we look at this, now we're going to start to plug in some points that we know. So we have negative 3, 0 is an x-intercept. Now if we look at this, there's kind of a problem, but not really. So we know that asymptotes are boundary lines, and that's something that our graph can't touch or cross. But if you look at that point, that x-intercept, that negative 3, 0, it's on the horizontal asymptote. Okay? That's okay. That can happen. The vertical asymptotes will never, ever, 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 ever be touched or crossed. The horizontal asymptotes, for the most part, are not going to be touched or crossed. Horizontal asymptotes are kind of more like suggestions, where they kind of guide your graph, as opposed to the vertical asymptotes that are strict boundaries. So majority of the time, if you have a horizontal asymptote that is y equals 0, you'll have points that touch it, but they're going to be like very close to that line. They can touch it, but they're not going to like go through it all crazy, and you'll see when we actually graph this. If we look at our y-intercept, that was 0, 3/5. So 0, 3/5 is like, I don't know, like here. Okay, so right now, I can't really graph this. I don't know what this is going to look like. There's these random asymptotes. I don't know. There's like 3 sections here going on. So now we need to pick additional points. So you always want to pick enough points so that you have, you can figure out the shape over here, the shape in between here, and the shape over here. So I would say pick 2 to 3 in each section. So here we already have 2 points. So we don't necessarily need to pick any more points since we know what this is going to look like. So since this is my asymptote, I know this is going to keep going towards my asymptote this way. And since this one's higher at this point, it's going to go up towards this asymptote. But I don't know anything about the middle, and I don't know anything about this side. So I want to pick a couple of points within here and a couple of points within here. So I'm going to pick, and again, you can pick any points that you want. You're going to pick the x, plug it into the equation, and find the resulting y. So I'm going to pick 2 as my x, since that's in that middle section, and then I get negative 5/3 for y. So all I did was plug 2 into this function, and I got negative 5/3 as my answer. I'm also going to pick 3, and I get negative 3/2 for y. I'm going to pick 4, and I get negative 7/3 as y. I'm also going to pick 6. So that's now on the other side of that vertical asymptote that was x equals 5. And I'm going to pick one more. I'm going to pick 7, 1. Okay, so once you get a hang of how to graph these and you understand what the shape is, the shapes are similar all the time. So once you have the generic shape of it, you might not have to pick as many points. But I'm going to pick up all these points now so we can see. So the first point I'm going to graph is 2, negative 5/3. So 2, negative 5/3 is like about here. Okay, then I'm going to graph 3, negative 3/2. So 3, about here. So it's a little bit higher than the other point. And then I'm going to graph 4, negative 7/3. So that's going to be about here. So we can tell that that's going to be like a little parabola over there. And then I picked 6, and 6 is 9/5. So that's about here. And then 7, 1 is here. So I can kind of fill this in. So I might not do such a great job, but we'll see if I can draw straight lines or not. So oops, this is going to go like this, and it's going to go up to here, and it's going to keep going up close to that asymptote. And then this one is going to keep going down towards that asymptote, and this one's going to go down towards this asymptote. And then this one, since we know that the point that's at 6 is higher than the other one, this is going to keep going up towards that asymptote. Always going to look like they're like symmetric or whatever. So, and here it has like 2 asymptotes, vertical asymptotes, will look something like this, where there'll be 2 parts that are kind of like mirror images of each other, and then in between them there's a parabola happening. And you've seen this in the iPad activity, like when we move the P. So depending on what the function looks like, it's going to look something like this when you have 2 vertical asymptotes. Alright, so let's look at this one now. So here we want to sketch the graph. So to find my horizontal asymptote, if I FOILed this out, I'd have x squared on the top, x squared on the bottom. So I know that my horizontal asymptote is going to be the ratio of the coefficients. Since if this FOILed, this would be like x squared something over x squared something. So the coefficients would be 1 over 1. So y equals 1 is my horizontal asymptote. I can actually simplify this, and I can cancel out the x minus 2's. So my new function is going to be y equals x plus 3 over x plus 1. So I'm going to box this because that's what I'm going to end up using for everything else. So the next thing is my vertical asymptote. So vertical asymptote is what I don't get rid of. So that's my non-removable discontinuity. So I did not get rid of x plus 1. So that's my vertical asymptote. So x equals negative 1. I did get rid of x minus 2. So I have a hole here. So I have a hole at 2. And to find the y value, I'm going to plug that 2 into the function. So 2 plus 3 over 2 plus 1 gives me 5 over 3. So 2 comma 5/3 is my hole. The x-intercept, I'm going to take the numerator of my simplified function, so x plus 3, and set it to 0. So x equals negative 3. So negative 3, 0 is my x-intercept. And then for my y-intercept, I'm going to look at the ratio of the constant terms. So my constant terms are 3 over 1. So my y-intercept is going to be 0 comma 3. And then we'll need some additional points maybe. So we'll write that down. Okay, so once I have steps 1 through 5, I'm going to start to graph it. So I have a horizontal asymptote at y equals 1. So at y equals 1, I have a dotted line. Oops, not very straight. At x equals negative 1, I have a vertical asymptote. So there's only one vertical asymptote here, so it's not going to have that parabola piece like that previous example. So I have a hole at 2 5/3. So I'm going to go to 2, and where 5/3 would be, and I'm literally going to draw a hole, like an open circle. And then I have my x-intercept is negative 3, 0. I'm going to go to negative 3, 0. And then I have a y-intercept at 0, 3. Okay, so I can kind of tell what this is going to look like. The right-hand side, I don't really need any extra points because I have one point that's higher than another point, and I have asymptotes that are bounding them to that region. But on the left side, I only have 1 point. So let's pick one more on the left side. So to the left of that asymptote. So I'm going to pick negative 4 as my point for x. And again, I'm going to plug it into my simplified function. So into the x plus 3 over x plus 1. And that's going to give me 1/3. So negative 4, 1/3. So I'm going to go back to my graph. I'm going to go to negative 4. 1, 2, 3, 4, and then I'm going to go to 1/3. So that's like about here. So that point's a little bit higher than the other point. So I can tell what the shape's going to look like now. This is going to go, this way towards that asymptote. And down towards that asymptote. And this side's going to go up towards this asymptote. When you get to the hole, it's literally going to stop and then jump over the hole and come out the other side. Oops, that's really not straight. Fine, but okay, so the graph itself does not go through the hole. It goes to like one side of the hole, it jumps over, and then it comes out the other side.